Welcome to Module Legends Math Techniques Edition. This is Sergio and I will be your math teacher for Quarter 1, Module 1.
16 triangles to form the fourth figure. The set of numbers 1, 4, 9, 16, 25, 36, 49, and 64 is called a sequence. A sequence is a function whose domain is the set of positive integers. It also means an ordered list of numbers. It can also be a list of numbers following a definite pattern. Each number in a sequence is called a term. The sequence can be expressed as 1, 4, 9, 16, 25, 36, 49, 64. The first number is 1, so that is our first term, 1. The symbol, like this, it is read as a sub 1 equals 1. The second number is 4, so we say second term is 4. The symbol, we read as a sub 2 equals 4. The third number is 9. The third term is 9. Symbol, a sub 3 equals 9. The sequence, again, are 1, 4, 9, 16, 25, 36. The fourth number is 16, so the fourth term is 16. In symbol, we say a sub 4 equals 16. The fifth number is 25, so the fifth term is 25. In symbol, a sub 5 equals 25. And the sixth number is 36. So the sixth term is 36. In symbol, a sub 6 equals 36. Sequences are classified into two. These are finite sequence, and infinite sequence. Finite sequence is a sequence with definite number of terms. It has a last term. So these are the examples of finite sequence. So say for instance, set of multiples of 2 less than 10. So this is the sequence. 2, 4, 6, 8. So how many terms? So there are 4 terms. How about number 2? Set of odd numbers less than 20. In sequence, we have 1, 3, 5, 7, 9, 11, 13, 15, 17, and 19. So how many terms do we have? There are 10 terms. Number 3, set of multiples less than 50, or set of multiples of 5 less than 50. So we have 5, 10, 15, 20, 25, 30, 35, 40, and the last term is 45. So all in all, how many terms are there? So there are 9 terms. So this is an example of finite sequence because it has a last term. Baga, walang forever. Infinite sequence. It is a sequence with no definite number of terms. It has no last term. Some of the examples are set of counting numbers. So we say 1, 2, 3, 4, 5, 6, 7, 8, blah 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 blah. So it continues the terms. Set of odd numbers, we have 1, 3, 5, 7, 9, 11, 13, 15. Okay, so the sequence continues. Set of multiples of 5, we say 5, 10, 15, 20, 25, 30, 35, 40, and it continues. The 3 dots is a symbol called ellipsis. This symbol means continue the pattern with no specific ending. Kung kanina, walang forever, dito sa infinite sequence, merong forever. The next term of the sequence can be determined by looking at its pattern. Example, what is the next term of the sequence 2, 4, 6, 8? In this sequence, the next term is obtained by adding 2 from the previous term. For example, the first term, a sub 1 equals 2. The second term can be obtained by adding a sub 1 by 2. So we say a sub 2 equals a sub 1 plus 2. Since our a sub 1 is 2, so a sub 2 equals 2 plus 2. A sub 2 now is equal to 4. Third term, that is a sub 3 is equal to a sub 2 plus 2. A sub 2 is equal to 4. So a sub 3 is equal to 4 plus 2, that is equal to 6. The fourth term, a sub 4 is equal to a sub 3 plus 2. Since a sub 3 is equal to 6, so we add 2 from 6. So we say 6 plus 2, a sub 4 now is equal to 8. And the fifth term, or the next term of the given sequence, can be obtained by a sub 5 equals a sub 2, or a sub 4 rather, plus 2. So a sub 5 equals a sub 4 is 8 plus 2, so a sub 5 equals 10. Therefore, the next term of the sequence 2, 4, 6, 8 is 10. How about the next example? What is the seventh term of the sequence? We have 50, 49, 47, 44, 40. Our solution would be, in the sequence, the next term is found by subtracting the previous term by the counting numbers. For example, a sub 1 is equal to 50. As what you can see, its pattern, a sub 2 is subtracted by 1 from a sub 1. So a sub 1 minus 1, a sub 1 is 50. So 50 minus 1 is equal to 49. That is our second term. A sub 3 from 49 becomes 47. So a sub 2 is subtracted by 2. A sub 2 is 49 minus 2 equals 47. So that is 47. A sub 4. So a sub 4 is equal to a sub 3 minus 3. So a sub 3 is 47 minus 3. That is equal to 44. So that is a sub 4. A sub 5 equals a sub 4 minus 4. A sub 4 is 44 minus 40. So a sub 5 is equal to 40. So as you can see at its pattern, you can now get a sub 6 and even a sub 7, that is the seventh term. A sub 6 is equal to a sub 5 minus 5. So a sub 5 is 40 minus 5, that is equal to 35. That is our sixth term. But as far as the question of this item is concerned, the seventh term, so we need to get the seventh term by looking at its pattern. So a sub 7 can be obtained by subtracting 6 from a sub 6. So a sub 6 is 35 minus 6 equals 29. So a sub 7 equals 29. Therefore, the seventh term of the sequence 50, 49, 47, 44, 40 is 29. Another example again. Number 3. What is the next term of the sequence 1, negative 3, 9, negative 27, 81? So in the sequence, the next term is found by multiplying the previous term by negative 3. Here, a sub 1 is 1. To get a sub 2, looking at its pattern, a sub 1 will be multiplied by negative 3. So, 1, that's the first term, times negative 3 is equal to negative 3, the second term. A sub 3 can be obtained by multiplying the previous term, that's the second term, by negative 3. So we have negative 3 times negative 3, a sub 3 now is equal to 9. A sub 4, multiplying a sub 3 by negative 3, so a sub 3 is 9 times negative 3 is equal to negative 27. A sub 6, multiply a sub 5 by negative 3, so 81 times negative 3 is negative 243. And a sub 5, a sub 4 times negative 3, that's equal to negative 27 times negative 3. So a sub 5 is equal to 81. So the next term, I think we are looking for the sixth term, a sub 6. Therefore, the next term of the sequence 1, negative 3, 9, negative 27, 81 is negative 243. Number 4, what is the next term? 5, 5 over 2, 5 over 4, 5 over 8, and 5 over 16. The sequence, as you can see, the numerator remains the same while the denominator is twice the preceding denominator. A sub 1, our first term is 5. Take note that 5 can be expressed as a fraction having a denominator of 1. So a sub 1 can also be expressed as 5 over 1. A sub 2 is equal to 5 over 1, that is the first term. It says that the sequence or the pattern will just multiply the denominator by 2. So 1 times 2 equals 2. So a sub 2 is equal to 5 over 2. A sub 3 is equal to 5 over 2, which is the second term. Multiply the denominator again by 2, so 2 times 2 equals 4. A sub 3 equals 5 over 4. A sub 4, 5 over 4, that is the third term. Multiply the denominator by 2, 4 times 2 equals 8. So a sub 4 equals 5 over 8. A sub 5, so 5 over 8, multiply the denominator by 2, so 8 times 2 equals 16. So 5 over 16 is the fifth term. And the sixth term, or the term that we are looking for, is equal to 5 over 16 from a sub 5. Multiply the denominator 16 by 2, that is equal to 32. So a sub 6, the sixth term is equal to 5 over 32. So therefore, the next term of this sequence is 5 over 32. Okay, moving on, a sequence can also be generated defined by the given rule. For example, find the first three terms of the following sequences. Number 1, a sub n equals 2n plus 1 all over n cubed. In getting a sub 1, or the first term, we simply substitute 1 for all n in the formula. So we say 2 times 1 plus 1 over 1 cubed. So 2 times 1 using PEMDAS, that's equal to 2 plus 1 all over 1. So getting the sum of the numbers in the numerator, 2 plus 1 equals 3 over 1. So a sub 1 now is equal to 3. In getting a sub 2, so we substitute 2 for all n in the formula. So we say 2n plus 1 all over 2 cubed. So simplifying, 2 times 2 using PEMDAS, 2 times 2 is 4 plus 1 all over 2 cubed. That means 2 times 2 times 2, that is equal to 8. And then 4 plus 1 is equal to 5 over 8. So a sub 2 is equal to 5 over 8. So getting a sub 3, substitute 3 for all n in the formula. So 2 times 3 plus 1 all over 3 cubed. So 2 times 3 is 6 plus 1 all over 3 cubed means 3 times 3 times 3. So 3 times 3 equals 9 times 3 equals 27. So 6 plus 1 is equal to 7 over 27. Therefore, the third term of this sequence is 7 over 27. So we have now the first three terms of the sequence, 3, 5 over 8, and 7 over 27. How about number 2? Given the rule a sub n equals 2n minus 1, 150 cubed. So once again, in getting a sub 1, we substitute the value of n, which is 1, to our rule or formula. So we have 2 times 1 minus 1 and then cube. So using PEMDAS, first is we're going to do the operation inside the parentheses. So we have 2 times 1, that is equal to 2 minus 1 cube. So 2 minus 1 is 1, then cube. A sub 1 is equal to 1 cube, which means 1 times 1 times 1, that is equal to 1. So the first term is 1. Next, a sub 2. So substitute the value of n, which is 2, to our rule or formula. So we say 2 times 2 minus 1 and then cube. So 2 times 2 is equal to 4 minus 1, then cube. So 4 minus 1 is equal to 3 and then cube. So it means 3 times 3 times 3. So a sub 2 equals 27. A sub 3, substitute the value of n, which is 3. So 2 times 3 equals 6 and then minus 1 and cube. So 6 minus 1 is equal to 5. Cube of 5, it means 5 times 5 times 5, so that is 25. So that would be our a sub 3 or the third term. Therefore, the first 3 terms of the sequence a sub n equals 2n minus 1 cube are 1, 27, and 125.
This has been your Sergio. See you on the next episode of our Module Legends Math Techniques Edition. Thanks for watching. Bye!